technological advances and changes in the external environment are steering the industrial paradigm rapidly. The importance of the materials, parts, and equipment industries is on the rise, and we are driving strategic vitalization all over the world. The material that will overcome the existing materials and come to the fore of the fourth industrial revolution, we call it graphene. A very specialized company which provides graphene total solutions. We are GrapheneLab. Graphene is a carbon atom material isolated from graphite and is arranged in a two-dimensional honeycomb lattice nanostructure. Graphene has superior properties to existing materials in tensile strength, thermal conductivity, and electron mobility, leading to active R&D for application in various fields. Superior graphene produced through excellent technologies and infrastructure can be applied to various applications by utilizing the characteristics. In the fourth industrial revolution, transparent electrodes for displays and ultra-lightweight and high-strength composites that are applied in aerospace parts are spotlighted as key materials. Graphenes are divided according to the synthesis method. GrapheneLab has a CVD method and straight growth methods, which are assessed to have high technical barriers. The CVD method has the great point of producing high quality in a large area, and the CVD graphene which is produced can be applied to FMM, transparent surface heating elements, and flexible materials. The direct growth method doesn't require a transfer process separately, can control graphene between nanometers to tens of nanometers, and has excellent uniformity in thickness. Based on the straight growth method, which is recently spotlighted, EUV pellicles can be produced to protect the photomask of the EUV exposure process. We, GrapheneLab, established our position as a CVD graphene expert company, including CVD graphene patterning, graphene surface resisting etching, doping, and OLED shadow mask process technologies, and which can be applied to semiconductors such as TSP mass production, OLED, and GrapheneLab has the know-how of designing various technologies and process facilities. GrapheneLab can manufacture large area CVD graphene films through our own RT-CVD process technology. The RT-CVD process can manufacture in a large area based on a lot of excellent characteristics. Compared to other processes, it is a highly difficult process, but we can mass produce through GrapheneLab's mass production technology. GrapheneLab built a one-stop process that extends from product planning to developing and providing customized products for economies of scale and application through mass production. For one of the processes, we adopted the tray method for the graphene synthesis part. Through tray method overcame the shortcomings of the traditional method, reduced production time, and enabled to mass produce of products. We secured equipment and systems such as RT-CVD synthesis equipment and large area etching equipment. Through this product equipment, we have manufacturing technology up to 1600 by 900. This can be transferred into PET and wafer. Also, it can be applied to various fields such as FMM and transparent plane heating systems. Because of a technological development, semiconductor devices becomes gradually miniature and more integrated. And for the implementation of the hyperfine process, the existing ARF immersion exposure process changes to EUV exposure process. EUV exposure process would need a thin film to protect the photomask from molecules and pollution in the atmosphere. The thin film, we call that pellicle. Among the various methods of manufacturing pellicles, GrapheneLab uses the mica method. When the metal catalyst layer and the amorphous carbon layer are laminated and heat-treated, the phase transition causes the metal catalyst layer rises and the amorphous carbon layer goes down and changes into graphene. The mica method has the great advantage of increasing process efficiency and forming equal thickness, and is not required for a separate transcription process. This technology and GrapheneLab's pellicle manufacturing equipment enabled to produce high-quality pellicle production. FMM is a subsidiary material that is used for depositing RGB in the required area and is essential for the OLED manufacturing process. GrapheneLab's electroplating method, based on the graphene technology, can overcome several limitations of the existing etching method. GrapheneLab's FMM is possible to generate uniform hole per unit area, enables the high-resolution implementation of more than 800 ppi. GrapheneLab's FMM has implemented a microcircuit through the electroplating process. After the electroplating process, which is a method of exfoliating the resist, is based on physical properties of graphene, the process yields reaches 90%. There's a great advantage for being easy to electroform due to its high electron mobility and possible to peel physically without damaging the FMM. Through this process, we can enhance the clarity of the display because it is possible to shape more than 800 ppi fine patterns. From small to medium-sized displays to AR/VR, the future direction of FMM will become a thinner and more high resolution. By overcoming the limitations of the etching method, GrapheneLab's electroplating process, based on graphene, which is thinner and easier to produce in a large area, is a solution for the future of AR/VR. A transparent plane heating system defined that is made by coating nanoparticles on a transparent material. GrapheneLab overcame weak points as existing transparent materials and developed CVD graphene transparent plane heating system that can generate stable heat at a low sheet resistance and cryogenic temperatures. The developed CVD graphene transparent plane heating system can generate heat up to 400 centigrade and maintain the temperature stably. So it can be applied to a variety of fields including polar cryogenic aviation, space, and automobiles. GrapheneLab, we are focusing on research and development to commercialize and mass-produce graphene. 52% of the company's workforce is composed of research, and we continue to research graphene manufacturing and product application. Also, by promoting technology partnership cooperation, we reinforce the technology of graphene source and application. GrapheneLab registered and applied for several patents, and we have the technology for developing and producing products by holding patents of Viserion plc, Korea Electronic Technology Institute, and non-exclusive licenses. As wearable electric vehicles and automatic driving technology, which are new industries, have accelerated development, and graphene, which has excellent strength and thermal conductivity, demands has increased. This is a major factor in the growth of the global graphene market, with an average annual growth rate of about 43% by 2025, and a market size of about $53.5 billion by 2025. FMM and EUV pellicle future markets are also expected to grow as demand rises. The FMM market is around $91.7 billion, and the EUV pellicle market is around $83.3 billion by 2025. In line with this global market movement, our government leads the roadmap for the commercialization of the graphene market, so we expect that the technology market will increase the amount of support for leading. The industrial paradigm changes rapidly, and graphene technology, which is the key to the fourth industrial revolution, we will provide a total solution that can be used in a high-value added industries. Based on technology and know-how that makes Korea into a material powerhouse, a leading technology company. We are GrapheneLab.